Question number 3.152. That in this figure an arrangement is given, okay, and that is infinite length connection between the wires, okay, and we have to find out the total resistance of this circuit. So let me draw this circuit first, okay, but for information it is given R1 is equals to 4 ohm and R2 is equals to 3 ohm. Okay, and we have to find out net resistance between point A and B. Okay, so let me draw the circuit first. This is resistance R1, then resistance R2. Again, resistance R1 and resistance R2. And this series is going for infinite length. Okay, up to infinite. And we need to measure resistance between point A and B. So we can assume that if out of infinite it will break one term, then it will not affect on the net resistance. So suppose up to this point we are getting equivalent resistance is R equivalent. Okay, so if we'll redraw this circuit between A and B, one resistance is R1, another resistance is R2, and it is connected in parallel with the equivalent resistance. Still there will be no effect, so from here we'll get equivalent resistance. Okay, so here we can take advantage of this concept that if you have infinite length combinations of something, then by removing unit length there will be no effect on the result. Okay, so from here we can write for this circuit that R equivalent is equals to R1 plus parallel combination of R2 and R equivalent. Okay, so from here we can write R equivalent is equals to R1 plus R2 into R equivalent over R2 plus R equivalent. So we can further simplify this expression, and from there we'll get R equivalent square plus R2 into R equivalent, which is equals to R1 plus R2 into R equivalent, right? Because this term is R2 equivalent and this is R1 R2, okay, plus R1 R2. There must be one more term, R1 R2, and this is R1 plus R equivalent and R2 plus R equivalent, right? Okay, so from here we'll get R equivalent square minus R1 into R equivalent minus R1 R2 is equals to 0. Okay, right. So this is a quadratic equation in terms of R equivalent. So we can find out the roots, that is R equivalent is equals to minus B means minus R1. So R1 plus minus under root B square, which is R1 square, plus minus, so basically we are concerned about plus 4AC, that is 4 R1 R2 upon 2A. This is divided by 2, right? So from here we can write R equivalent is equals to R1 plus R1 common under root 1 plus 4 R2 over R1 and total divided by 2, right? Now we have R1 and R2, so we can substitute here. So R equivalent is equals to 4. Let's take plus minus. Finally we'll settle it. Under root 4 under root 1 plus 4 into 3 divided by 4, right? And total divided by 2. So this is 4 and 4 are cancelled out, so this is 3 plus 1 4 and under root of this is 2. So we'll get 4 plus minus 8 divided by 2. So definitely there is no negative resistance as far as electrical circuits are concerned, although negative resistance is there for semiconductors, but here we'll take only positive one. So from here we'll get equivalent resistance for this circuit is 6 ohm.